On popular demand, I'm posting the final exam questions from fall of 2025, CS 6212 algorithms at GW. So this question was with a difficulty level of very easy, expected score 10 out of 10, and students should have spent about 10 minutes on it. Many students did get 10 out of 10, but unfortunately, not everyone did. In this case, we're given two recurrence relations, T of n and R of n, and we are supposed to compare T of n is equal to 6Tn by 2 plus n square, R of n is equal to 4Rn by 2 plus n 2.5. In this case, we're going to follow two simple steps. We're going to simply solve them independently, and then we're going to compare. In some cases, the recurrence relations can be compared without solving them, but that's not the structure here. So in this case, we're just going to go ahead and solve them independently. Let's solve the first one. T of n is equal to 6Tn by 2 plus n square. In this case, we simply use the Master Theorem. We're going to compare f of n square, with log of n powered log of 6 to the base 2. That's a and b. So therefore, we get the conclusion that T of n is equal to theta with the larger term, which is n powered log of 6 to the base 2. So that's T of n. Similarly, we solve R of n. R of n is equal to 4Rn by 2 plus n powered 2.5. Again, we compare n powered 2.5 with n powered log of 4 to the base 2. And therefore, because 2.5 is larger, therefore R of n is equal to theta of n powered 2.5. Now in this case, we go ahead and simply compare. We want to compare n powered log of 6 to the base 2 versus n powered 2.5. We don't know the log values. We're not supposed to use any calculator, but we can simply take the powers of 2 on both sides. Therefore, we compare 6 versus 2 power 2.5. We may not remember the square root of 2, etc. So therefore, we can simply take the squares on both sides. We get 6 squared versus 2 power 5, and clearly 36 is larger. Therefore, log of 6 to the base 2 is greater than 2.5, and that's our conclusion. So therefore, we get T of n is equal to small omega of R of n. In this case, we should be using the proper asymptotic comparison operator. That's small omega, not just say greater than. And also, we should not write big omega because in this case, it's strictly larger. So there you have it, a simple question from the algorithms final. And I hope that every student who gets a question like this gets those 10 points easily and then moves on to the harder questions.